the final differentiation lesson is on differentiating sine and cos. So the best thing to remember for this is Snapchat. So Snapchat is SC, but we're actually remembering Snapchat, but we've got a negative S and a negative C down here. So that S is sine, cos, sine, cos. Now think about when you're differentiating. When you differentiate a function, you decrease your power. So if we decrease down this column, we are differentiating. Now, there is a topic coming up that the opposite of differentiating. So this will come back into play then, but for just now, we'll just remember that Snapchat, you work down differentiating. So what that means is if you have the function sine and you differentiate it, you get cos. If you have cos and you differentiate it, you get negative sine. Negative sine, differentiate it, gives you negative cos. And at the bottom of that, you would then go round and start again from the top. So negative cos, if you differentiate it, gets you back to sine. So just remember that rule and you'll be absolutely fine with this. So if we're differentiating y equals 5 sine x, so dy by dx equals, so if we differentiate a sine function, it becomes a cos function. So this is just going to change to 5, sine goes to cos x. Okay, and that's our final answer. This next one's a little bit different because we've got this cubed in it. So that function can actually be written as 2 cos x cubed. So remember, cos cubed x and cos x cubed are the same thing. So this is what we can then differentiate. Now thinking back to your last lesson, you are allowed to differentiate with brackets now. And to do that, we use our chain rule. So this is going to be differentiated using the chain rule. So we bring our 3 down, multiplies by our 2 to give us 6. Cos x stays where it is, and we decrease that 3 to 2. Now remember, with your chain rule, you then have to multiply by the derivative of the bracket. So in this case, our derivative of our bracket is going to be negative sine, because if we're starting off at cos, we then move down to negative sine. So we're multiplying by negative sine x. That can then get tidied up and gives us negative 6 sine x. And I'm going to get rid of that bracket and write out cos squared x. And that's my final answer. So that's a combination of trig differentiation and the chain rule. This next one, it's set up as a bracket already. There's nothing that I need to change in that. I'm quite happy with the format of that. We can go straight into differentiating this. So that 4 is going to come round and going to give us 4 cos x plus 7. Decrease that power down to 3. This is your chain rule again, so we're now going to have to multiply by the derivative of the bracket. So if we've got cos x plus 7 in our bracket, when we differentiate cos, we get negative sine x. And again, that can be tidied up to negative 4 sine x cos x plus 7 cubed. And that's our final answer. This next one is new again. If you compare y equals cos 4x to this first example of y equals 5 sine x, notice that your number is in a different place. So this one has to be treated a little bit differently. And the way that we treat that differently is by putting brackets round this 4x. So again, this is going to be part of your chain rule. So when we're differentiating this one, we've got dy by dx. Start off, if we differentiate cos, cos goes to negative sine, and that 4x is going to stay exactly where it is. We now need to multiply by the derivative of the bracket, and if we differentiate 4x, we just get 4. Tidy that up, we've got negative 4 sine 4x, and that's going to be our final answer. Next example, so very similar to the last one, we've got a sine, but we've got a 5x minus 3 in a bracket. When we differentiate, we get f dashed x. So differentiating sine, it gives us cos. That 5x minus 3 stays exactly where it is, and we now need to times by the derivative of the bracket. 5x minus 3, differentiate it, gives you 5, so that can be tidied up to 5 cos 5x minus 3. And that's the final answer for that one. Final thing that you could be asked to do is to then substitute in values. So for this one, it wants us to differentiate it and then find out what happens if we sub in pi over 3. So this one, we've got two separate functions, but the same as with a normal function like you're used to, you do it in separate parts. So if we find an f dash x, so remember Snapchat, these two are negative. If we differentiate sine, we get cos, so sine x goes to cos x. This time we've got a negative cos x, so if we differentiate negative cos x, remember this one goes back up to the top, and we're going to get a positive, and it's 2 sine x. Now remember, that 2 just stays exactly where it is. You only have to take it into account when it's in between here, but right now it's at the start, so it's just staying as 2 sine x. We are asked to find f dash pi over 3. So replace all your x's by pi over 3. So here we've got pi over 3 plus 2 sine pi over 3. Now obviously, if you know your exact values with your radians, that's perfect. Go ahead and use them. If not, then you can change this into degrees and use it with degrees. So pi is 180 divided by 3 gives you 60. Using your degrees with your exact values, you're probably a lot more familiar with. But cos of 60, or cos of pi over 3, is a half. 2 sine of 60, or pi over 3, is root 3 over 2. But remember, this is getting times by 2 as well. We've got that 2 there. So that's then going to give us a half. Our 2 and our 2 can cancel each other out. So plus root 3. Now that's quite messy writing that like that. I would write it all as one fraction. So remember, to do that, you have to find a common denominator. If we come up with our common denominator, essentially what we're doing is going back to this line here. So in simplified version, that would be 1 plus 2 root 3 over 2. And that would be your final answer. And that would be the answer that your calculator would get you to as well.